Hi everyone, welcome to my Twitch today. We're gonna do some list of something really interesting. You can see it. You can't see my screen yet. So I just wanted to say hi to everyone who joined so far. And Gwen Rest, I hope I said it right. Yes, I am German actually. And the flower that you liked so much, that is actually from here in Colombia. Went to the mountains, Cocoy, climbed to almost 5,000 meters, and it was snowing, but you could still see the flower, so that was nice. As always, if anything is not good, let me know. If you can see something well, if you can't hear me well, if the music is too loud or something, let me know about that. Okay, so I'm going to share my screen now. You should be able to see my screen at this point. Hey Beto Moretti, how are you doing? Thanks for joining. So we're just about to start. So the music today, I actually found a playlist from the Möber crew, which is Creative Commons. So the idea is that I don't want to have the sound, like whatever I'm explaining, be removed because we're streaming with copyrighted music. So that's the whole reason why I'm using Creative Commons. I have a bunch of other favorites that I would like to put, but can't do that because then if I archive the video, you couldn't hear what I said, which would kind of suck. Okay, so today we're going to do decorators. So decorators, we're going to first explain what they are a little bit, and how you can already use them today and why we're doing an alternative. So first of all, decorators are proposed to actually be part of the JavaScript spec. Actually, let me 1 second. The music for me is a little loud. If the music for you is also a little loud, let me know. So now music should come back for you guys. Okay, so decorators. Basically, a decorator, we are going to focus on method decorators, so like functions in JavaScript, right? And in this case, it's going to be class functions, class methods, however you want to call it. And what usually a decorator does, it takes the original function that is decorated and does something to it, like it will wrap it. So for instance, you could have a function that is automatically it logs something when you enter the function and it logs something when you exit the function. Or what we're actually going to look at is you can like bind a function, or I had another idea where you could declare a function as async, and if it's async, then some other tools could say, oh, I want to actually promisify that automatically. So you can use it with a callback API, or if you're like, async await, you could use my module with a async await or promise API. So here we have the proposal. This also includes, for some reason, the private field proposal, which private fields will be prefixed with a pound. So what's happening here is we put a bound here, and then magically somehow this function will be bound. So that's kind of the idea there. That's the proposal for the TC39. There's some other blogs out there that explains this really well. So basically the idea is that what happens is if we have a decorator around a function, it will pass in information about that function to the decorator. So in this case, it will pass in the target, and the target is basically the instance. So it's basically the this of the component, right? And it's going to pass in the name of the function and the descriptor. So basically, the descriptor has a bunch of stuff on it. We're going to look at that in a second. And with the descriptor, what we would do, we would basically replace the value of the descriptor, basically replacing the function with another function that does something to the original function. So that's kind of the idea, right, of a decorator. So here we have another explanation that I found. This is, it looks to me like it's Python. Python already has decorators. The idea here, we explained a little better how the what we get passed into us. So we get everything passed into that you would normally pass in to define a property. So the value would be the function, right? And here we have the prototype passed in, name of the function, and then the actual function, and then some other kind of values. And so here, actually, in this example, what they're doing, they're saying we want something to be readable. If it's read-only, right, we're going to change something about it. Let me find this. Let me find, well, the point is that what they're basically doing is they're going to change the descriptor and say configurable false, and then pass that back. So you get the same function, but basically it's now only, you can't change it anymore after that. Now, there are already decorators in the wild. Like I said, there are already solutions for this, actually. For instance, Develop It, I think you also created Preact. He has a few decorators, bind, debounds, memoize. I actually like this more instead of like bound, because it's more about like what we are doing to the function, right? So I want to bind this function, I want to debounce this function. And he's basically using a bubble plugin. And so that's the transpiler, right? So that will basically go and say, okay, if I find a decorator on a function, I will generate some code that's actually ES5 code or whatever code you want to transpile to, right? Basically, in the end, there won't be the decorator declaration on it, but you can basically use this kind of attribute. It's not valid JavaScript. And so I have a few problems with that. One is that some editors, obviously, that don't understand this, or linters, they will not work anymore, right? Because they don't know how to interpret this thing. Like, what is this? Because it's not part of the JavaScript spec yet. In the browser, if I'm transpiling for the browser, that's actually fine, because you always have build zip for the browser anyways. Like, you have to bundle ES6 somehow, so it's not a big deal. But I also like to stick to actually JavaScript that's implemented, and that's implemented in a current node, so I can just run my file directly. So I don't have to, if I'm just like playing around with things and I'm trying things out, I want to be able to just like run the file immediately. I don't want to have a build step in between. And I know you can include the bubble runtime, but that's another kind of thing that, that's in there that kind of is another layer of indirection that I don't like too much. So, and you know what, the other reason is I just wanted to play around. I just wanted to see if we can solve this without without transpilation. And I want to do some meta programming in JavaScript, and I hope you will also find this interesting. So funny enough, this module is called Deco with a CK, but since we talked about I'm German, there's a word, Decoration, which is the same as in English decoration. So our module that we're going to do is going to be called Deco, here, DEKO, and I found out that's still available on NPM, so that's great. By the way, if any of the code is too small, let me know, because I can't see what's being streamed as it's being streamed, so I don't know exactly how you guys are seeing it and grows. Okay, so that's I looked through the source here a little bit. He has some interesting conventions. We're going to see if we can actually write our decorator library in a way that we could actually use these decorators that already exist. That would be kind of ideal. But for today, the idea is just to play around, just to see if it's even possible, how it would be possible, maybe think about the best way to do it, good API. So I already did a little bit of research, and basically looking at what do we actually need to find out the functions that, like how do we find them? How do we find the decorators? So the idea is that we'll basically have so if you, for instance, have onClick, right? So I'm just going to comment part of this code out, and I'm going to show the problem, right? So basically, here we have a world class, right? And we'll get to why this is in these in this block scope in a second. But so you have a class blocks world class, right? And onClicked, I want to say this.hello, right? So I need to be bound. However, if I want to pass the onClick function to like an event handler, I would probably do it like this, right? Or a lot of times you say, we say onClick equals this dot on click, that, you know, like on clicked, kind of like, let's say in a React kind of thing, right? You would have, I don't know, the button, right? And now suddenly this dot on clicked, right, is not, obviously it would be in these things, but you all know what I'm talking about. Now this dot on click is no longer bound. It just has the function, but it's not calling it on this directly, so therefore it loses the context. So what you then will do is you say this dot on clicked equals this dot on clicked dot bind this, right? And you can do that. That's fine, but I kind of wanted to find a better way. That's at least one reason to do decorators. Obviously, there are also solutions for that, where there's a module by Syndosaurus, I hope I say his name right, where it basically has auto bind, and it binds everything. So that's kind of cool if you want to bind everything or most of it, but if it might have performance overhead, right? Because you're binding everything, and you might not even need half of what you're binding. So see if we can do a better solution. So here we're going to run this file, and we're going to find the problem right away. So here we see console log this.hello cannot read property hello of undefined, right? And as you can see, I always just run my files like this, which is the reason why I don't like transpilation when I'm just working on stuff. So basically what's happening here is I assigned this function. It's kind of lost its context because I'm calling it without, you know, I'm not calling it on world class dot on clicked, right? So if I was going to do world class dot on clicked, right, that works fine because now again I have my this context. Okay. So the idea is like, how do we make that work? So let me comment that. How do we make that work? We don't know. So how do we first of all, how do we tell our whatever we are creating, how do we tell it that we want to bind this function, right? So we could have a separate array to do that. We could have, we could do this way. I actually did a spike where I tried another API, which is a little bit ugly. So basically where you define your function actually as a getter, and then you have an array, and the first part is an array of decorators, and then you actually pass the function that's actually going to be on clicked, and then the thing magically reaches decorators and replaces the function, blah, blah, blah. But this kind of looks ugly, and you're kind of indented now. I didn't like it too much. So let's get back to what we are. So I found a better idea. I figured we could call a function with the same name, but we prefix it with something. So I thought about like prefixing it with like $1, but then there are probably a bunch of jQuery people maybe that wouldn't like that. I know that's kind of a convention there. So we'll just use $2. So we could do something like this, right? And then all that function does, it just returns the decorators, right? So, and that's kind of what you probably saw in my, in all these tweets that I put out. I had bound in there. So on all the tweets I put out, I had kind of this API. So that's kind of what you're shooting for. And you could arrange it like this, but then I saw that this kind of looks nice. It will cost $2 for every use. Yes, Clark, you got that. And you can donate these $2 on my Patreon, and the link should be right there. So thanks for bringing that up. If you use my module, $2 for each function that you use, I'll be a rich man. Okay. So, where were we? Only joking, of course, right? All right, so this is kind of the API we're shooting for. And so now we're going to go step by step. So what I'm actually going to do is we're going to play around with this in a sandbox. So first of all, I will comment everything out except this part. I'm going to show you some tool that I have. It's called RepelPad. So let's go and show you guys RepelPad. So this is a tool that I created a long time ago, and the idea is, oh wow, I got vulnerabilities, but this is like a tool that you use for development only, so it should be fine, but probably should fix it. So this is kind of a tool that is kind of like a node REPL, but every time, so I'm going to do this, I'm going to play around a little bit with the Twitch features. So every time that you actually save your file, it will then update the REPL automatically, so you don't have to load every time you change a file into the REPL. I haven't updated this for a while, so it didn't work with ES6 this afternoon. And so I updated really quickly some dependencies on it and pushed to a branch. So if you actually want to play along, if you want to play with REPL pad with ES6, I'm going to show you how to install it. Unfortunately, it doesn't work like that easily yet. You actually have to install it locally. It's a little bit painful, but if you want to try it anyways, that's fine. So what I did, basically I did npm, let me actually look at my history, should be there. So I did, where did I do this? Oh, I can see this, okay. So, but what I did is I basically installed, right, I is fine. But I didn't install it directly from the registry because right now it's kind of in the works and the tests don't pass, so I can't really push it. And then I call it ES6. So basically there's a branch on my GitHub repo. So this is the magic of npm. If you put it like this, it will now go to my GitHub repository, we'll find REPL pad, and then it will find this branch, ES6. And then it will basically add it to your package, package JSON like so. So now it has it like this, right? As a def dependency. And well, as you can see, I still had the previous install in here, which I should remove, which didn't work 100%. So let's remove that. And then I added a script to just run REPL-pad. Why do I have that? Well, because REPL-pad is inside the spin directory, right? And I don't want to say /node modules all the time. And npm does this magically for us. It will actually prepend this path for us, so we can just run it like this. And the dot that I have there is to tell REPL-pad, please watch the current folder. So if I do run REPL-pad, then basically right now it's telling us a bunch of things and it's telling us that it's watching our pad file. So now what I can do is I can just go over here and save, and magically things appeared over here. And so the class is not available. Why is that? Well, because I have this block here, right? So everything that's in that block will not bleed outside that block, right? Otherwise, if I do it this way, there's a problem. I'm going to show you guys. If I do this, right, I saved once. Now, if I save one more time, it will tell me world class has already been defined or declared, right? So I can't declare the same class with the same name twice. So you'd have to restart REPL-pad all the time. So to avoid that, we can do it this way. However, everything that I want to kind of use and inspect, I just have to attach to the global. That's just for, you know, playing with it in the REPL. Okay, so for instance here, unexpected identifier. What does it mean? Why? Oh, because we forgot an equals. By the way, if you see me making mistakes, try to be faster than me catching it. So now we have the class, right? So now we can play with it. Another way to do this, by the way, I'm just going to show you this. So if REPL-pad is not working for you, whatever. So you can launch DevTools, and there's a cool feature. You find it inside sources, where you have snippets. So you find the network folder, and next to it is snippets kind of thing. And you can actually execute these things in the browser. And again, here we also had to do the same thing to put it in the block, so we don't have to restart the console. So if I press Command-Enter on Mac, probably Control-Enter on Linux and Windows, it automatically ran that script. And then what we also did, we added globals so we can inspect them. So for instance, here we can do a desk, and then we can print them out. So that's really useful as well. If you just want to play with stuff in the browser. I always use that if I, for instance, like yesterday, I was trying to print out something from a page. And so basically I would, would print it to PDF, but then there would be the header and it would always cover some part of the PDF up, which was annoying. So I wrote a script real quick to remove that, and I could keep working on it until I had everything removed. Really, really cool feature. So, but we're going to use REPL-pad today. So, okay, so we had the class. We're not going to make that actually global. So now we're going to actually look at some things. I already found the method that we most likely need. So what is that method? The method is get own property descriptors. That's the magic method. There are other methods, so you can go to MDN and the object. It has a bunch of cool features on it. For instance, you can also get one property descriptor, but then you need to know the name already. you can also just get all the names. So basically then I would find all the method names. So basically it would tell me that I have an onClicked here, which would be cool. And actually it's probably enough. Why is it enough? Because you just want to call it. However, to avoid kind of confusion, we want to make sure that it's actually a function, right? So we want to actually get a little more information, but that would probably work almost as well. So basically what we're doing here, we're creating the class, but this is not an instance of the class. We are just assigning world class to class. And why are we doing this? Because later on, most likely, we will wrap this all in the API. So I don't want to have it hard-coded world class everywhere. I'll kind of already prepare for, pulling this out into a nice function that we can actually use. And again, most people are talking about, test-driven development. I'm kind of more like example-driven development, where I just play with something until it works. And then I kind of already have code there that kind of executes the function. And then usually I will just go later and convert that into a test or multiple tests. And as far as I know, some other people are doing it that way too. I tried for this kind of thing, when you don't even know how it's going to work yet, test-driven development is really not the ideal way of doing it because you don't even know what your API looks like yet exactly. So, okay. So let's save this. And now actually what it did, it printed out global.descriptors because assigning descriptors to global.descriptors returns the descriptors. And so RepoPad automatically printed out the result of the last assignment or last line of code that I ran. So, so what can we see here? We get a length property, we get a prototype property, and we get a name property. We don't really see our onClick property. Okay, so that's interesting, right? And does anyone want to guess why that is? And why I'm waiting for an answer, I'm going to show you how we could actually get to it. So if you do this, if you do the prototype, we can actually see this function. But we want to kind of, right, this should be declared once. It shouldn't be a kind of like an instance method, right? It shouldn't be on, let's say on the prototype, it's kind of like more of a hack, right? That we're only going to use in our tool. Like we don't even want this to be on the prototype. So how do we do this? Does anyone want to guess? I'm gonna keep doing this. Maybe we'll get some answers. Okay. What we can do, we can make this into a static method. And now watch, if I save now, I'm actually getting onClicked here with the $$ as a showing up. So that's pretty cool, right? Because the idea is this. We could obviously pull the decorators from the instance, like you create a new world class, you give that to me, and then I do that. But then we would do that every time you create a new world class. That's not ideal at all. What we want to do is we basically want to have some code here that sets up the world class as far as I can, at least pulling out the decorators so it knows kind of what decorators to apply, right? So we're kind of trying to get as much done as we can while we're just initializing our module, right? Okay, so we got the descriptors. So that's pretty cool. And so what do we need to do now? We need to get all the descriptors that have $signs in the beginning, right? So let's then say const a decorator. Let's call it descriptors. Seems really long, but we'll see. We basically filter these. So what do we get here? Oh, we get actually an object, right? So we'll have to say we have to either enumerate through the keys. That's probably a good way to do it. So so actually we're going to make that into a function because that is going to be. So let's say decorator, get decorator descriptors. Or get decorator. Oh, look at that. You know what? I did this function already, so I'm going to cheat a little bit to make this a little faster. So this was a little more complex. You can see that it gets really complex with this solution. So our solution is going to be easier. So let's get. Actually, it's not decoratables. Those are the actual decorators, right? Decorator function descriptors. right? And so we give it all descriptors. Okay, and then we're going to say the keys. Static is supported in ES6, as you can see. So I'm running, if you see, look a little at the top, node, REPL is actually telling me what node I'm running. I'm running node 8, the latest version, and node never, so that's like the big difference with node. Unless you're using bubble runtime, node only has features, given that you're also not using any weird flags to turn on things. Node only has features that are actually part of the spec. Right, so it's also just running directly with V8, right? So anything that runs with Node will also run with the latest Chrome at least, right? Because Chrome also runs V8 under the hood. So yes, it is supported, but for instance, something that's not supported, let me comment that to show. Something that's not supported, some people are doing something like, I can't remember how this goes. So like a bound hello would be something like this equals, right? And then you can do that, right? And then you have a function. That doesn't work. And actually my linter will tell me, and then here it tells me also unexpected tokens. That's not even part. If I try to run this file as well, it will tell me this is not allowed, right? So, and I know some front-end frameworks or like libraries are using that already because they are using they're using features that are not even part of the spec yet or are not even supported yet, but the transpilators basically make that possible, right? And you're welcome, Beto Moretti. Okay. So now, so const keys equals, so object dot keys of the descriptors. And then what we'll do is we'll just write a simple. We just do it simple. We're not going to go too crazy functional. We're just going to say the decks, whatever, are empty. All right. And then what we'll do is we'll say go through all the decorators. So for const, and this is another feature that's lately supported for each key of keys. And why am I doing this? Because I don't want to have to create another function. So like if I'm using an actual filter function or if I'm creating a map function, now I have to create another function. This is also kind of nice. So for all key of keys, if the key, right, if it doesn't start with $, so we could do this with the regex or we could use starters. And now here comes the cool feature of REPL. So we can just jump over here, make a little string, right? And play with it. So let's do that. That's a valid one. And so we say s.starts with. So we get top completion. Obviously, most of the features are available in the plain node REPL as well. But some, like I have Vim bindings here, by the way, so I can go jump backwards. I can jump to the end. So some of those are not available in the node REPL. Okay, s starts with $. Yes. So however, if we make our s like this, then it doesn't start with $. Anymore, right? But I mean, that's not really possible if you have a function. How would you add spaces? Couldn't do that, right? But let's try another one. Let's just try one that only has $1, and let's try it again. Okay, so starts with works really well, and I would argue that starts with probably is a little faster than using a regex. So if the key starts with, and we're going to say we are using kind of like early exit, right? So we want to kind of rule out all the cases we are not interested in. And so we're going to say continue. So in a function, you would always return if you have a filter function or something, but we're just going to say continue. And but if it does start with it, what we're going to do, we're going to push the actual value, so the descriptors of key, we want to push it on the dex. That's it. And then we return our dex. Okay, so now we can actually call that get decorator descriptors. I should probably close that other buffer, but it's fine because you get all this kind of highlights from the other file. Okay, so Gross. All right, cool. So let's see what that does. So now we're going to say, we're just going to keep it the same name, decorator descriptors. Just going to kind of send the same to. Okay, now look at that. We got a value. Wooden prototype. Yes, but the idea is that we want to limit the user to use kind of static functions. Oh, you mean like starting? Oh yes, you're right. I could maybe. You're right. I could maybe do that. That's sturdy. Don't do that. I mean, so like yes, if you want to fool our library and make your own life harder, you can. But I hope you're not doing that. So we are not. But I mean, most likely you're not going to do it like that. And then we'll just won't find your function. And maybe we'll, that's a good point though. Maybe what we should do at some point have at least like some diagnostics to where you can kind of say, okay, I'm going to pass a diagnostic flag, and then the library will kind of print out, hey, I found this decorator on this function, this decorator on that function. So if you're wondering why it's not working, at least you have a clue. And actually, if some of you are aware of browserify shim, that's what we did there, because there's could be pretty complex setups that you have and configurations, and then it really helps if you can at least have an idea why things are not working. So good idea. We should probably make sure people don't shoot themselves in the foot even if they're trying. Okay, so now we got all the descriptors. So now what we'll do, we have to map those to decorators and to functions. So basically what we have to do is we have to make sure that the value is actually a function, right? This one here. We have to make sure that's a function. And then we have to call it, and then we get the decorator. So basically what we'll do is, in this case, our descriptors, right, that we have. And then the first one is going to be the one that we have, right? So right now we only have one. Okay, right? So now we should say dot value, and we should be able to call it. And then it returns the decorator. See how that works? So let me do that on. I'm realizing that sometimes like my terminal still prints at the bottom. By the way, if you want me to make the terminal be more on top, let me know as well. I could do that like this, because I know it's kind of hard to see, and I'm always typing at the bottom. I realized that from my other streams. Okay, so now we're actually pretty good. We got the decorators. So what we'll do is function get decorators or something, right? So okay, so and that's basically from our decorator descriptors. Long names, but we'll live. So now what we have to do is we'll go we go through all of them. And this time though, we're actually going to use a map. This is all ES6, right? And my guess is that maps can be optimized better than just hash functions or like hashes, at least in the future. So we are going to actually use an ES6 map. So if you have questions about ES6 maps, let me know. But the best way to learn about them is just to always, everything you want to learn, is just type mdn and whatever you want to learn. And then, well, sometimes it works, so that's not what we're looking for. We're looking actually for this map. So here you can learn all these, the whole API about the map. And I believe that in the future, this will at least be optimized. I'm not sure if it's already faster or not. So what we can do is we go now through all our decorator descriptors. So of decorator descriptors. And we'll say that, first of all, the value has to be a function. So if it doesn't have a value, something went wrong. So if d.value null, well, actually, we kind of covered that, right? If we say the type needs to be a function, it also can't be null. So type of d.value equals triple equals function. So And then basically we're going to do the opposite. Again, we're going to do early exit. We're just going to continue. We're going to ignore that one. So here probably, right, we should, though, at some point, give some message, right? Hey, you had this thing, it had this name with $2, but it wasn't a function, so I couldn't really do anything with it. I couldn't even pull the decorators out. I don't know what you're doing. Probably should at least warn you if you have a diagnostic flag turned on. So if it has, so now if you have a value though, then basically we can say, so let's just say, so how do we get the name? So, okay, so here we made kind of a little mistake. Not a mistake, but we could have made that nicer, right? So let's actually change it, because now we have to actually ask the function for its name, which is kind of not cool. Why didn't we already include that when we actually pulled them out here, right? So maybe an array wasn't like the best solution. So let's instead say you get the document descriptors, and the decks are actually also a map. And then we add, right? We add, and in this case, we could add the key, right? But we could actually be smarter and say that we are more interested in actually, you know, the function that we are trying to decorate with it, right? So, well, let's do that actually in the next step. So we'll do one step at a time. So here we'll just basically get the full name, which we'll execute, and then we'll basically replace that because to get to the function that we're actually trying to bind, we have to remove the $2 signs, right? Or the $2. So now actually, first of all, let's see if this works now. Okay, so dex.add not a function. Okay, so I think it's set. There you go. So add, I think, works for the set, no pun intended, and set works for the map. So now we have a map here, right? That's pretty cool. So now basically we have a map, we have the name of the thing, and then we have the same thing. And the cool thing is with the map, we can iterate the same way. And we can say, this is a key, and then this is a value, right? So basically what we're doing, we're using destructuring here. So it might be that it is like this. If anyone knows, well, I'm still typing. I think it's it works like this. Key value pairs out of a map. So we got the key. So this is the actual decorator, and that's the key. So now if we found one that we actually want to use, then what we'll do is we'll actually replace the first two $ signs. And there are several ways of doing it, because they replace the first two, we use a replace function. But we could also just say a slice. We already know it's the first two things that we are not interested in. So we can use the slice function. So, so the name that we're trying to decorate equals basically just key.slice, and we start at 2. So again, if you want any kind of explanations, let me know. By the way, slice has this cool thing where you can say slice, but up to the last 2, you can actually pass a negative number here, which is kind of cool. So we got the name now, and what we can do now, we're going to add that to our map. So add, but the thing is though, this could all crash, right? So if you're doing something weird in here, we're gonna crash. So we're gonna fix that all later, right? Today is hacking day, so we're just gonna hack. But we can already see some problems here, right? So we have to. So what we'll do later is we'll add a bunch of tests that make our things crash left and right, and then we'll make sure that we pass all the tests. So we add the name, and we add the. Thank you very much, Gwendolyn. Nice, you guys are actually watching out. Okay, so now we should be fine, and all right, cool. So now we got that map. So const decorators equals get decorators from the decorator descriptors. Okay. And then, so now we're going to actually change that. We're going to say decorators equals decorators. Wow, look at that. It worked. So obviously now I'm just going to demonstrate some weird problems here. If I forget, for instance, to return, I don't even know if my linter will catch that. Yeah, it doesn't catch that, right? So now we got nothing. So that could happen. That some people misunderstand this. So there are a bunch of things that we need to warn. Now, obviously, if I throw an error here, now we're also going to have a problem, right? So a lot of things that we still need to fix at some point. Okay. Okay, cool. So let's continue here. By the way, for everyone who just joined, we are building decorators that work without transpilation. And so far, basically what we did, we have a static method here that says what the decorators are. The convention is we're using $2 in front of the name of the function we're actually trying to decorate. And so at this point, basically, we're as far to where we know, we want to decorate this function with bind, okay? So that's actually pretty nice. So let's recap. This one still doesn't work, still crashes. If I call onClicked, it does. Well, we say cannot. All right. Cool, right? So just recapping to make sure that we still have a problem, because I think we're pretty close to where we can actually have something that does something useful. So now we got the decorators. So now we basically need to say every time you create a new class, you need to decorate it. So what we need to do is we have a decorate function, and what we're going to do, we pass in the instance, or let's call it the target. So the target is basically, if we create a new world class, that's going to be our target. So it's not going to be the class itself, it's going to be the instance of the class. So in this case, it would be that little world class here, right? So that's our target. And then we have the decorators. And later on, we can have options, right? Because we could say, apply all decorators, but don't apply bind. Or, you know, for this decorator, I want to pass some specific, for instance, if you have a debounce, right? I want to pass a kind of a timeout for the debounce. But we won't worry about that later. So now, got that. So here are the decorators. So basically what we'll do is we say for, and you can see I kind of like the whole, right? So this is a name, and this is then the, what do we have? So we had decorators, and okay, so this is basically a function name, right? So fn, the function that we want to apply to. Let's be 100% clear. And then these are, this is kind of the decorator array. Right? Let's call this decorators map, just to be, so we can call this decorators, because this is like a, you know, so this is nicer. So we say of decorators map. Okay. So then, what we'll have to do is we're going to say that the original function, original equals. So now we actually want to get the descriptor, right? So what we're going to do, we're actually going to first be really, really simple, and we're just going to get all the descriptors to make sure this actually works. Descriptors. And this is just going to be an array for now. So the original is actually, and now we're going to use another function that I showed a second ago, get own property descriptor. So if we know the name, right, we can say get the own property descriptor of this instance, and this is the name, right? So that's exactly what we need. Object.get own property descriptor, right? And by the way, for those interested, I'm obviously using Vim here, and I'm using turn in the background. So I'm using a plugin for Vim called Vim Turn, which uses turn in the background, which constantly is kind of running my JavaScript in order to give me this nice little syntax highlighting. Not syntax highlighting, but IntelliSense, so to speak. I think that's what it's called. So we want to, let's go back to the function. We want to give it the target and then the name, right? So target, name, dfn name. Or, okay, so there you go. Make this a little bigger. Okay, so now we got the original. Let's call this a descriptor. And we're going to, just to push it, we're going to go step by step to see how we're doing. Right? And then we just, from here, we return the descriptors. In the future, this will probably not return anything, right? Because it will just decorate stuff and then it's done. So you want to say const descriptors equals decorate. And then, so now the decoration has to happen actually after, right? So let's do this here. So now we actually have to already give it an instance. Obviously, for the people watching and kind of watching out, we could also give it a prototype. So we could attach it to the prototype, or we could do stuff on the prototype, but for instance, for the bind, that doesn't make any sense because we actually need to bind it to the instance. So for now, we'll just always bind to the actual instances, right? We're not going to, we're going to decorate for each instance instead of on the prototype, which probably is also possible. So descriptors, we give it the world class and we give it our decorators, which up there are called decorators map. And then, so this is a trick you can only do in REPL-head. You can just say, I want to see what this is. And then descriptors has already been declared. Oh, look, we got that. One sheet, I'm going to make this a block. If you do this, it should print out. So descriptors are undefined, right? So there's some problem there. Seems like it didn't find one. But first of all, look at that. We did. There's something weird that we did here. Oh, we didn't use the decorator set. Well, this is actually okay. Get own property descriptor. Actually, yes, there's some noise. I'm staying with other people, and they're doing things in the background. So no ghosts, real people. Okay, let's think about why this does not work. So so what are we actually going to do? I'm going to show you another way how you can nicely debug things. We're going to put a debugger statement here. Line, they are called the same. 38 and 39. Yeah, I mean, but this is another decorator. So this one we are just not using yet. So we could as well call it this. Oh, look at that. And now, so we got the original one, but we didn't get. So the thing is, okay, so yeah, so they're called the same on line 48 and 55. But since I'm using this block here, right, I'm right, line 41 refers to the inner definition. Yes, that's what I want. But to the inner, which inner definition? This definition I want to refer to, right? So I think I should be fine. Never mind. Thanks for trying to help, though. Yeah, I always need help. I can't read either, so need everyone's help. Okay. So we return the descriptors, so something's not working. So I'm going to show another way how to do this. We're going to put a debugger statement here. And what we're actually going to do, we're going to run our code with Budo. So, which is kind of a cool thing also. So let's make it out of here. Let me clean out my... Okay, so Budo is a cool tool. I already have it. Sorry, I already have it globally installed, so I'm not going to install it again. but at least I can show you what it is. So it's this cool thing where you just say boodle, give it a file and open or whatever, and it will just run the code in the browser. So then we can debug. Obviously we could also use Node to debug, and if anyone is very interested in showing how I can inspect this, whereas this for instance like an Express app and we couldn't run it in the browser, then let me know. But for now we're just going to use boodle. So I'm going to run my pad with boodle. And so now we should have this over here. And then we open the DevTools. Okay, and so we're gonna run this again. Okay, now we pause our debugger. See how easy that was? It's kind of cool. So again, to recap, all we did, we ran our file with boodle because the code, right, is not Node specific. It's just JavaScript, right? So we can run it with Node. We can use RevelPad, but we can also just run it in the browser. And in this case, I wanted to debug something, so it makes sense to do that. So right now, to see what we have a decorators map, which has an onClick function, which points to an array. Okay, so that's fine. So we should actually, so now we step, okay. So, okay, so now we got the target is our world class, but look at that, it has nothing. It's on the prototype. So basically our world class itself, so if we say get property descriptor of this thing, doesn't give us anything, right? But if you get the prototype first, so if we say object.get, and I know there are other ways to get the prototype, but this is now the official way. So we're going to do the official way because we are streaming. Ah, look at that. So now the prototype, and now we actually get something back for our value, right? And it's our onClicked. Okay, so that's what we have to do. So that was really useful, and I'm going to actually keep that running. In case we need it again. So it's kind of good to have all these tools at your disposal. So, you know, sometimes it makes sense to use RevelPad, but in this case it makes sense to go to the browser. It's just one thing I would suggest to everyone watching who hasn't done it, familiarize yourself with kind of all the tooling while you have time, because when you actually really need them, you won't have time, right? So, it's kind of a fun vegan project. So what we're going to do is get a prototype of the target, right? And so you could say, why didn't we just pass a prototype then? Well, because we only want to, again, we only want to change it for that target, right? Because we might even have, you know, do it different for specific instances, blah, blah, blah. We don't want to mess with the prototype. Okay, so, and now basically we're looking for on the proto. And then we should now get values. Yes, we got our map onClick. Is that what we wanted? Let's see. Oh no, well, we didn't prove anything yet. We have to still do this. Okay, now, okay. So we got descriptors. Obviously, like if we wanted to reuse them, like we would have to create another map. And maybe actually would, maybe that's a good idea. What do you guys think? Do it in 2 steps. Like first get the decoratables. So basically what we have here is, what we could do, we could say, this is a function we're trying to decorate. Yeah, I think that's easier to then debug. So what we'll do is we say, find decoratables. It's always good to go in steps. So here we have a new map now. And so this is so these are the decorators. So we get the descriptors, and in this case, this is like, let's call them the decoratables. So these are the ones we're going to decorate. So we're going to say decoratables dot set, and we're going to say this is the function name, and then we're actually going to put a bunch of information in there. We're going to save the target where we're going to apply this, and we're going to apply the we're going to save the decorators that we are going to apply, and obviously we also have to save the descriptor. So this should be fine. And by the way, I'm using ES6 syntax here. In ES5, whatever, you still have to do this, but you don't have anymore because thanks to destructuring. So now we return the decoratables. And so now we obviously need to find decoratables. But you can kind of see that we're finding the decoratables, but specifically actually, you know what? This is kind of an interesting thing. Since this is a prototype, right? We could actually find the decoratables first without even the target. And we can even do that. We can even do that before we instantiate the class, right? So that means we would be better performing because we can do that all at initialization time. So even better reason to. So what we're actually going to do is let's pass in the class, and I think this should also work. So now what we'll do, we don't have a target anymore, but we'll only need that target when we actually apply the decorators, right? So that should actually work. So basically what we can do now is call them decoratables. Find decoratables, and we actually give it the class, which is the upper world class, right? And the decorators, which actually be consistent with the naming here a little bit more. All right, so and let's just print those out. Tables. FN names not defined. All right, look at that. So now we got on-clicked. The decorators are this. The descriptor is undefined. Think about that. Yes, so basically the descriptor is part of the object. So we can't get the descriptors yet. So what did you actually gain here? We know we had that before, right? We didn't gain anything. So yeah, so it seems like we have to undo what we just did. We didn't really gain it because we had that information before, right? We knew the decorators, we knew the function name, didn't really gain anything there. So let's do the target. So let's do it this way then. Now we should actually have the descriptors. Right? So we're going to call them decoratables. So decoratables. See what happens now. Target is not defined. Oh, we have to actually, yeah, to rename that. All right. Well, we undid our fix. So, by the way, I should have seen this, right? Because I have actually a version of standard. It's a custom version of my standard. By the way, if you're hearing the dogs, I am sorry, but there is a bit kind of a dog, kind of doctor place close, and sometimes they bark. All right, so now that worked. So what I was going to say is I should have already actually seen this with my linter, right? Because my linter already tells me about these problems, but with ReproPie it's really fast as well. So now we got on-clicked. The target is a world class. The decorators are bind, and the descriptor is this. Look at that. So now all we have to do is apply the what we found, right? So function decorate, and so we give it the target again and the decoratables. And so what we'll do is we go again through all, we go through decoratables. So it's a map, but in a way we don't, what's funny about this is we don't even need to know the name. Probably still nice to have it, but basically all we're going to do is replace, well, we do need the name because we need to name it on the target, so it's fine, we have it. So so the fn name is called again like that, and then we have the decoratable. So let's call it X. Kind of lazy. It's pretty obvious what it is. It's a decoratable. Decoratables. And what we'll do is we'll save the original function. And that's basically part of the descriptor. So x.descriptor.value. Right? That's the original function. Let's make clear that it's a function. Okay. And then what we'll do is we'll bind that function to the target, right? And replace it that way. So we do x dot, in this case actually we don't need the name because we can actually just change it right in the descriptor. Value equals, right? And we'll say that we want the original function bound to our target. That's it. And that should actually have an effect now on our class. So let's see if everything works, if anything crashes. So now we have the world class, found the decoratables, and then we decorate the world class with the decoratables. And now this is kind of a big moment, right? Because either it works, decoratables, or it doesn't. So let's see if something crashes already. Nothing crashed. So now, right, this should work now. Or not. It should work. Can't reprove undefined. Did not work. Okay, so let's think about it. So we didn't use the, so this is interesting. It seems like we cannot just overwrite the value, maybe. So we're not using fn name, that's fine. So let's think about this. Let's actually put a console log dot in here. X.descriptor value to make sure we actually have a bound function now. Okay, so we printed undefined, which is interesting. That is interesting. So why? Oh, sorry, I made a mistake there, right? Descriptor. So as we can see here, we did assign onClicked and is bound. But it seems like somehow just overriding the decorator didn't. Ah, does anyone see why? It's because we're doing this. No, actually, this should work. So we're doing this after, that's correct. So let's think about why is this not working. So the other way that we could do it, obviously, we could just say, we could just make double sure, we could say target. So we could do it this way, right? Target of the function name is this. And now it works. Okay, so that's how it works. Okay, but I thought we could just change the value of the descriptor. I guess we can't. Interesting. So let's then actually, after we do that, let's then print the descriptor value. If it changed, maybe there's some magic going on we're not aware of. See, it's still not bound. So this one didn't change. Ah, I know why. I know why. Haha. So basically, the cleaner way to do this is to change the descriptor like we did, At least I have a working version now, right? But we can say then object dot define a descriptor. As you can see, let's look that up on MDN because I can remember how that worked. So on the object, right? Let's just look it up. MDN define descriptor or define property. Let's see how that works. Very nice. So they're thinking we are now in. So they realize we are in Colombia, which is correct. That still doesn't mean that I prefer English. My Spanish is not quite that great yet. So this looks like, yeah, this looks like what we have, right? So we got the object, we got the property. Let's look at an example here. So we get the object property, but it gives it a value which is, I'm just hoping that it's not like a getter or something weird. Is there something like something just for property descriptor? Set prototype, no, it doesn't seem to be. Define property, define properties. That seems to be the only thing that I can do. Okay, so we'll do it that way. So object define property, and we give it our object, we give it the name, and we give it our new descriptor. So that seems to be the more correct way to do this. So the target, the name of the property, and our. So actually what we can do also, we can say, right, our new descriptor, well, let's not mess with that, let's try that later. So is this descriptor now. So what it would do, it would override, so the prototype most likely would still have, yeah, prototype would still have the old version, but our instance would have the new version. So, oh, look at that. We got node to crash with RepoPad. There's some file watcher going on, and sometimes it crashes. So look at that, it still doesn't work again. Oh no, well, what was the function called again? Does anyone remember? It was called define property. Now it works. Look at that. So now we're going to play around with making this a little nicer. Because what we're going to say is our descriptor is the original descriptor. And I'm using spread syntax here. And yes, if anyone's wondering, that is part of proper ES6. You could also use object.assign. This is just a little shorter, that's all. So we're spreading out the values here. We make sure we don't overwrite the original descriptor, even though that's not important in this case. So now it should still work. It's not used. Okay, so that's fine. But look at that. I was lying. Okay. So I was wrong. It seems to be not supported yet. Unless I did it wrong, but I'm not aware that I did. So we can do, we want to make sure we don't overwrite the original descriptor. So we do it this way. Let's actually put this on multiple lines like this. The first value makes sure that we create a new object. Then we'll take all the values from the descriptor and we overwrite the value. So that should now work. We need another, yeah, this should actually work. Shouldn't be supported. Okay, well, I was, see, that's how you can get confused if you do a lot of front end and you use a transpiler. You get you know, I wasn't aware that that wasn't supported because I've been using it in the browser. The delay of the streaming or of the sound, or the delay of the implementation of these features. Anywho, I hope everyone can hear me fine. I hope there's not too much delay. Let me actually look at how my stream is doing. There's a way to check that. Let's see. So it looks like we have an okay bitrate going. It says excellent. So shouldn't be the stream. Oh, okay. Well, Twitch is telling me the opposite. Twitch is telling me I have an excellent stream. So I'm very sorry if there's delay for a lot of you. Not anything I can do about, but we'll just keep going and I hope it'll improve. So, so we pretty much can decorate now. This actually works. So we have to pull this out into an API. So actually what we're going to do now, we're going to close this down and we're going to clean things up a little bit. And this is kind of where I wanted to get today. I wanted to basically just figure out how this could work and if, and at least have some sort of an API. And in the next next episode of this, we're actually going to then you know, clean things up even more and add tests as well. So let me actually split this. So we're just going to pull all these functions over. Weird, interesting about the support. So maybe I actually had, maybe I made a mistake. Oh, weird. What? Well, we don't know what version I'm running in here, and so that's another thing. I might be running in a different version. Well, what we can do, we can actually do console.log process.versions, and we'll find out what version I'm actually running. So I'm running, well, I'm running 8.9.1 here. So the other one was 8.9.4. I don't think it changed between these patch versions, right? So maybe I made a mistake. So we find decarables and decorate. That's pretty much all that's part of the API. So now we just need to have one function that kind of does it all. Yeah, so the thing is, RepelPad was basically running it with a different version of Node that I'm using in my Vim, which might be surprising. But basically, as I said, RepelPad had some problems. So I installed with nav, with a version controller, I installed a different version and ran RepelPad with that version. So I was running a slightly newer version of Node with RepelPad. Okay, so basically, what do we have to do? We have to, there are a few things we have to do, right? So this is a two-step process. So first of all, we have to prepare the decorations, right? And then we have to apply the decorations. So how is a nice API? So right now we got this all pulled out. So in my opinion, it needs to be a class, or because it will have state, right? Because what we'll do is we'll create this this deco, and then we'll pass in the static class, and then it will basically look and already pull out all the decorators that need to be applied, and then we'll just pass in an instance every time we need to actually decorate things. So obviously, we need to keep the decorators around, so we don't have to do that every time. So let's call this deco. And so we keep, so usually you wouldn't do options right away, but there's really no cost anymore. So nowadays when I do APIs, I always already start, even if I just have one argument, because now I can open myself up to infinite additions to the API without breaking existing code, right? Obviously, you could also say, well, you could take multiple arguments, but now that's kind of hard to follow, right? Like and remember the order and so on. So what we'll do is we will get the decorators. So we say this dot decorators equals get the decorators. So we actually have to do this step by step like we did before here. So we get the descriptors, we did the decorators. So here we go. Copy that over. And I don't like to have these things directly in the constructor for some reason. It doesn't seem clean. So we'll do that instead. And we basically say this dot class equals class. And then we say this dot decorators is this. And then all we have to do here, actually we'll just call init with the class. It's easier. You don't really need the class after that. And for those of you hanging around, thank you very much. You're almost done. So what's the difference between reflection and transpilation content? That's an interesting question. So basically, what we're doing here, we're kind of doing some meta programming where we are reflecting on the living things, right? So the code is actually already running, and we are taking the world class. That's actually, even though it's a class, it's also an object, right? It's in JavaScript, right? So I would these things so that you would even get a. So let's just try this real quick to make sure I'm right. But maybe we don't actually need that all the information. But basically, the code is already running while we're doing our things, right? So while it's running, we're going and we're reflecting. We're kind of looking what properties does it have, what are the names, and so on. That's kind of reflection. You can do that in all kinds of languages. Transpilation basically works on the code before it's running, right? So basically, it works on text. So how it works is you give it your JavaScript that maybe has some features that are not even part of JavaScript yet, right? And then what happens, it basically creates an abstract syntax tree. So what that means is it takes all the text and it tries to understand the code, right? Because it has to do that first, because now the next step, what the transpiler will do, will actually rewrite that code into some other code. And that other code is in a format that works with older browsers, or that maybe has, so if you're using features that don't even exist yet, right, it works in with the browsers that only have features that do exist. Another thing you can do, you can, for instance, even take a totally different language, right? And you can transpile it to JavaScript. Why do we not call it compile? Well, because it's still text, right? It's not like binary code. So for instance, if you think about C, there we give it a text file, but it spins out a program that just runs by itself and has basically machine instructions, right? It's not text anymore, but transpiler goes from one text to another form of text that, you know, all the browsers basically understand. So I hope that was clear. If it wasn't, let me know and ask more questions if you want. We're kind of nearing towards the end here, but I'm actually pretty happy. We got a lot of stuff done. I just want to get this API to a point where our pad will basically run. So then we can basically have an example already that we can push into a README, and then we'll probably just, I'll show you my little tool that can init a GitHub repo really quickly. So we'll use that, and then we'll just copy the files over. We'll kind of cheat. So where were we? Decorators. So we got the decorators, right? And then we have a function that is kind of public, and we'll say decorate the target. And the thing is that you can actually call that from the class itself. So we're going to try to see if we can get the class to decorate itself in the constructor. That would be awesome, because then it's all really super maintained. So where were we? So we got the decorate, and that needs to just call decorate. So actually that we're just going to put this code right in here. Okay, so Ikan, you can always watch it later, but something to just read up on. But memory reflection of the memory. If you're talking about like kind of looking at what's in the memory, or like looking at a heap snapshot, you could probably call that reflection also, but that's not what we're talking about here. But yeah, have some time out. This video will be online on my Twitch for a while, and I think it's good enough to where we'll actually also export it to YouTube, and it will be there forever. And I'll post that link on Twitter. So follow me on Twitter. My Twitter is, I'm just gonna put that here. My Twitter is TH_Lawrence. Make that really big so everyone can see it. What happened now? Okay, went over here. Okay, that was too big. It restructured. Oh, there you go. TH_Lawrence, right? So follow me there, and you will always get the latest and greatest information. And I will post where I put that video. So decorate, we got that. We got the target, right? And we just need to say off this dot. Okay, so you get the decorators, but you don't have decoratables yet. How do we get that? Okay, so decoratables we have to find. So we find the decoratables of the target of this dot decorators. So are you trying to figure out where I'm from, Kankan? I am German. The name is Scandinavian, that's correct. Lawrence is actually a very common German last name. Nice to meet you. I was actually in Sweden, I think twice. I really like the country. Yeah, so yeah, first name is Norwegian. It's also very common in Germany, that first name. So, where were we? The decoratables. We got that. This should actually now work. Let's save. Let's see what happens. So we got deco. We need to obviously export it. So the way we export it, we could obviously export it just as a kind of like export the class, right? But now you have to know that you have to new it up. So what we actually we're going to export it like this, and you're going to pass in the class, and then we're going to return you a new deco with that class. However, I'm really against time here. We may actually push this then in the next episode. We'll see. Maybe I'll go a little overtime. Type faster. Create deco. That's our export, right? So basically what you'll do, you get the deco, give it the class, and then later on you call decorate on it. That's the plan. So what's going on here? Oh, we're not using that function anymore. Linters are so awesome. So if you're not using a linter, you're missing out. You should start using one. So this is now our example. We don't need these things anymore. So we got the. So let's see how we can do this. So in the constructor, I wonder. See, that's a tricky thing, because. So by the time we hit the constructor, world class already exists. So we should actually be able to say. But yeah, actually what we would want is we would want to create this deco statically, right? Or we could cache it. That's actually a good idea. Actually deco should be smart enough to cache by himself, right? If we already created a deco for this exact class, then we should not create another one. So we'll get to that maybe in the next episode. So for now, we're going to say deco. So we're going to make this a getter. I'm just going to call it deco. And we'll say this dot deco equals. No, actually, we don't need to. Just need to say, well, actually, if we do it outside the class, it's a little nicer. But let's just do it this way. No, we can't use this. That doesn't work. So what we'll do is we say world class dot deco equals create deco. So basically of the class is world class. And obviously we have to import deco first. Do it quick like this. So let's just delete all this for now. See, make sure this actually runs. Okay, so we made a mistake over here, right? We have to new, but at least now the whoever's using this doesn't have to remember that. Okay, so that's good. So we got the deco, and now basically what we want to do is we want to say this dot, so that whatever we have on the class should also be available as this dot deco dot decorate. From this, kind of weird, right? Let's see if that actually works. So if we create a new class now, world class, new world class. Let's see if it, let's first see if it crashes already. Can't read property of decorative undefined. Okay, so that didn't work. So let's use this one. Okay, that worked. So it doesn't matter where we could also keep it outside of the class, but for now we do this. So now, right, so we decorated it. That means that now we should be able to say clicked or unclicked, right? Equals world class dot onClicked, and then we should be able to say onClicked, right? Yes, it worked. So we got this to kind of a two-liner, right? I mean, it's not such a big deal, right? You just add that to make your class decoratable, and then you just have to remember to call that in there. Well, you also could do, so another way to do this is obviously to say get world class, right? And then you just decorate it. So you can even then make it optional to decorate or what kind of things you want to decorate. So obviously that works. So we leave it simple for now. And because we want to just use this as an example. And we're going to put that in the README in a second. So I think we're doing pretty good, actually. So what I'll do is I move this thing to deco for a second, and you'll see why. So I'm going to go to deco, and then I'm going to make it first, and then I'm going to cd deco. And so the cool thing is that I have the script and start, and I basically say I want tests with tape. So I put a -a, and then it will do everything. So I say, actually I had a really nice description already, and now it's probably all gone because, yeah. So we just want to paste that in. Decorators for ES6, there you go. I don't have to think of how to do that again. Oh, we have to. That didn't really work, so let's do that. This way, there you go. Now it's initializing the repo on GitHub. You should be able to see this now. I'll paste the link. There you go. Deco appeared out of nowhere. So you can look at the code if you want. Once it's up, right now we have nothing up there. It just created a bunch of tests, but we can then say deco. We're going to copy Decorator.js here, And we're also going to copy the pad that we had. We're going to put it as an example. Okay. Then we're going to cat the example into our clipboard. We're going to go to the README, and we're going to put the example there. Okay, so that's cool. The whole testing and stuff we're going to do next time. So nothing there yet, so we're going to leave that README like this. And we're just going to add these two files. And we're just going to git commit amend to the original one. So let's call this core initial and then we'll have to force push, right? Because pushing over. So obviously that test is not, there's nothing in there yet. We're gonna have to set up Travis. We'll all do that next time. But the idea is that now you should be able to go to that repo. I didn't want to refresh the chat, sorry guys. And obviously all my chat messages are now gone, at least in that one, but I still have it here. Here we have an example how this works. And there you go. So we got an example, and I think we're pretty good. And next time we'll add some more. Obviously, we have to test that this works, and then the idea is that so we have one decorator, right? But that's kind of baked in there at this point. So what we want to do, we want to separate the decorating from the decorator implementation. So the bind decorator would live in a separate folder at least. And the idea is also that we most likely want to publish, the, so it's actually right now, as far as I know, we didn't even look if it was a bind decorator, we just bound, right? So we want to say, okay, if it's a bind decorator and you have a module that knows how to bind things, then we'll actually apply that bind decorator. And so the idea is that these decorator implementations actually live outside of Deco, right? So decorator just does the decorating, but then the community could come and implement tons of decorators that work with Deco. And as I said, I ideally also want to implement it in a way where we can use existing decorators that are written for when you transpile your code, but they could also work in our case. And most likely to keep things kind of simple and together, we'll still maintain our decorators that we create inside the same repo, but with their own package JSON, and we'll publish them as separate packages. So if you just, you want Deco and you want maybe one decorator, you're not installing all these other decorators with it, right? So thank you very much for watching. I will tweet in a second or like over the weekend, and I'll ask what's the best time for most of you to watch me if I do this in the weekend, in the week. And then I'll see when I continue. Most likely we'll continue on Wednesday, 6 p.m. That's the usual time we have, 6 p.m. Eastern time. And thanks, Judy. I enjoyed it a lot, and I hope you learned something. I definitely did. So see you all next time.